Hey guys, coming at you with an enthralling video about math. We're continuing the series in geometric proofs, covering some of the common vocabulary words you will see in geometric proofs. Please keep in mind, geometric proofs are pretty difficult for many students, but it's a worthwhile skill to gain control of. It promotes logical thinking through issues. If you ask me, a skill set that's seriously lacking. For this video, we're covering congruent parts of congruent triangles are congruent, or better known as CPCTC. Often, the issue we have with congruent parts of congruent triangles are congruent, or that statement, is when to use it. So that's what we're going to talk about today. We're going to go through the definition of congruency. We're going to look at different ways to prove triangles are congruent. Then we're going to look at the definition of CPCTC. Then we're going to do a proof using it. So let's get started. So congruency. Congruency can be defined as identical in every way. It's a physical concept in geometry, not a numerical one. So we're not talking about how like 5 equals 5. We're talking about how this triangle monster is exactly the same as this one in every way. Every angle is the same, every side is the same. And that's where CPCTC is going to come in. Okay, let's look at how we prove triangles are congruent. So, we have side, 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 which is use 3 pairs of sides, which when you have that, you could prove that these two triangles are congruent. You have side, angle, side, which is 2 pairs of side and a pair of angles included. So when I have side, angle, side in this order, I can prove that these two triangles are congruent. I have angle, side, angle, which is 2 pairs of angles and 1 pair of sides included or in the middle, which is a way to prove that these two triangles are exactly the same. I have angle, angle, side, which is 2 pairs of angles and a pair of sides not included. And that's how I can prove these two triangles are congruent. Just keep in mind the differences between these two. Then I have hypotenuse leg, which can only be used on a right angle or a right triangle where we have a hypotenuse and a leg that are congruent. Okay, let's take a look at the definition of CPCTC. Okay, so the definition of CPCTC, as mentioned before, is just stating that congruent parts of congruent triangles are congruent. In other words, once I prove 2 triangles to be congruent using the previous 5 methods, once I use those, I can make this statement about any part not listed in the proof. So I can say, once the triangles are congruent, that any part of those triangles are congruent. This is very important, and I'm stressing this. This can only be used after the triangles are proven congruent. You cannot use it before. For an obvious reason. It's stating here that the triangles are congruent. So if you say the triangles are the same, that means each part within the triangle has to be the same. You cannot say it before you make the statement the triangles are the same. I'm harping on that part of this because often students that do not have strong control of proofs start writing CPCTC all over their proof, hoping to get the problem correct. And it couldn't be more wrong there. Okay, so this is a proof I used in a previous video for perpendicular lines, and we're just going to use it again. I changed the proof part from proving the triangles are congruent to proving that the angles of the triangles are congruent. So let's take a look. It's worth practicing how to use perpendicular anyways. So I copied down the given. I have the reflexive side here, so I'm going to write that down. So I have DC is congruent to DC, And that's because of the reflexive property. Okay, now I'm going to use the perpendicular part. I'm going to write that, I guess, in blue. I only have so many colors to use here. So, because of the fact that I have the lines intersecting perpendicularly, that means they make a 90-degree angle. So first I'm going to state that I have a 90-degree angle. I'm going to say angle ADC and angle BDC are right angles. And that's because of this. So let's get that in there. The trials and tribulations of being left-handed. Let's get that a little nicer. There we go. Then I'm going to use those right angles to prove that the triangles, or to state that the triangles are right triangles. Because I'm going to be going for hypotenuse leg here. So I'm going to say triangle ADC and triangle BDC are right triangles. And to shorten this, to make my life a little bit easier here, I'm going to say it's a property of a right triangle. That's listed above. Property of a right triangle. Now, from there, let's see, I have the hypotenuse listed, I have the reflexive side, I have the right angle, so I can make the claim that triangle ADC is congruent to triangle BDC because of hypotenuse leg, because of that form of congruency. Now I could use this because here's the deal. I proved that these two triangles are the same. And in doing so, if these two triangles are the same, every part that's not listed in this proof above has to be the same now. So these angles are the same because the triangles are the same. These angles are the same because the triangles are the same. AD and BD are congruent because the triangles are congruent. So I can make that statement now, not before. So I'm going to say that angle A is congruent to angle B. Angle A is congruent to angle B because the triangles are the same, or better known, CPCTC. Okay? It's often written like this. I'm going to sneak this in here. Congruent parts of congruent triangles. Whoops, they don't use the word, they actually put the symbol there. Triangles are congruent. So you may see it written like that, or you may see it written as CPCTC, or you may see it written out, congruent parts of congruent triangles are congruent. Okay guys, that's the video for geometric proofs, concluding with CPCTC. I hope you guys found this video helpful.